Welcome back, everyone. Today, we're diving into the fascinating world of terraforming Mars, the science and technology that could one day turn the red planet into a livable home for humans. From altering its atmosphere to generating water and heat, we'll explore the bold ideas scientists are considering. Join us as we uncover the challenges, breakthroughs, and possibilities of making Mars habitable. Don't forget to subscribe for more mind-blowing space content. Number 5. Atmosphere Boost. Atmosphere boost is one of the most critical steps in making Mars livable. Currently, Mars has a very thin atmosphere, composed mostly of carbon dioxide, with surface pressure less than 1% of Earth's. This low pressure makes it impossible for humans to survive without protective suits, and also prevents liquid water from existing on the surface. Boosting the atmosphere with increased pressure and trap more heat, gradually warming the planet. Scientists suggest releasing greenhouse gases, such as perfluorocarbons, into the atmosphere to create a stronger greenhouse effect. Another idea is to use large orbital mirrors to reflect sunlight onto the surface, indirectly heating the planet and helping release gases trapped in the soil and polar ice caps. Over time, a thicker atmosphere could also provide some protection against harmful solar radiation and cosmic rays, making it safer for future human explorers. This process is slow and would require advanced technology, but it lays the foundation for other terraforming steps, such as growing plants, creating liquid water, and eventually introducing life. Without an atmosphere boost, no other step of making Mars habitable could succeed, making it the first and most essential challenge in the journey to a livable red planet. Number 4. Surface warming. Surface warming is a crucial step in making Mars habitable, because the planet's current average temperature is around -60 degrees Celsius, far too cold for liquid water or most life forms. To make Mars livable, its surface needs to be warmed significantly. One approach is to increase the concentration of greenhouse gases, such as carbon dioxide and methane, in the atmosphere. These gases trap heat, gradually raising the surface temperature. Another method involves deploying large orbital mirrors to reflect sunlight onto the Martian surface, providing additional heat in targeted areas. Warming the surface would not only allow ice at the poles and underground to melt into liquid water, but also help thicken the atmosphere, which is currently very thin and unable to retain heat efficiently. Over time, a warmer surface could support plant life and eventually human colonies, creating a more Earth-like environment. This step is essential before introducing complex life forms, as it lays the foundation for water cycles, weather patterns, and energy balance necessary to sustain ecosystems. Without surface warming, other terraforming efforts, such as introducing plants or building habitats, would face extreme challenges due to the harsh cold. Number 3. Water access. Water access is one of the most critical steps in making Mars livable. Mars has vast amounts of water locked in its polar ice caps and underground ice reserves, but to sustain life, this water needs to be made accessible in liquid form. Scientists propose melting ice through methods like using orbital mirrors to focus sunlight onto the surface or introducing greenhouse gases to warm the atmosphere. Once liquid water is present, it can form rivers, lakes, and even small seas, creating the foundation for ecosystems. Accessible water is not only essential for human survival, but also for growing plants and supporting microbes that will eventually help transform the Martian soil. Additionally, water can be split into hydrogen and oxygen, providing fuel for rockets and breathable air for settlers. Efficient water management will also involve storing and recycling water within habitats to ensure sustainability. The challenge lies in maintaining liquid water under Mars' low pressure and cold temperatures, which requires advanced engineering solutions. By successfully establishing reliable water sources, Mars can begin to support life, making this step a cornerstone of the terraforming process and a vital prerequisite for all other efforts to make the planet habitable. Number 2. Soil fertility. Soil fertility on Mars is a critical step in making the planet livable, as it determines whether plants and other organisms can grow successfully. Unlike Earth, Martian soil lacks many essential nutrients and organic matter needed to sustain life. It is rich in perchlorates, which are toxic to most plants, and is extremely dry, making it challenging for crops to take root. To improve fertility, scientists propose adding nutrient-rich compounds and organic material to the soil, such as compost or specially engineered fertilizers. Another approach is introducing beneficial microbes that can break down minerals and release nutrients. mimicking the natural processes found in Earth's soil. Over time, these microbes can help create a more balanced ecosystem, enabling plants to grow and thrive. Additionally, hydroponic or controlled greenhouse systems can be used as an intermediate step to cultivate food, while the natural soil is being improved. Developing fertile soil is not just about growing plants. It is essential for producing oxygen, food, and a self-sustaining ecosystem. By transforming the barren Martian surface into arable land, humans can establish colonies and support long-term survival on the Red Planet. Number 1. Life Introduction. Life introduction on Mars is the final and most ambitious step in terraforming the planet. After creating a stable atmosphere, raising temperatures, providing water, and enriching the soil, the environment would become suitable for sustaining living organisms. Initially, scientists would introduce hardy microorganisms and extremophiles, organisms that can survive in extreme conditions, to test the stability of the ecosystem. These microbes could help recycle nutrients, produce oxygen, and prepare the ground for more complex life forms. Once the microbial foundation is stable, simple plants, algae, and mosses could be introduced. These species would gradually increase oxygen levels, improve soil quality, and create a small-scale biosphere. Over time, more complex plants could be cultivated, forming the basis for forests and grasslands, and eventually supporting animals in controlled habitats. Human colonization would follow only after the ecosystem proves self-sustaining. Advanced technologies, like controlled domes and life support systems, would assist in this transition, ensuring humans can survive while the planet's natural systems develop. The ultimate goal of life introduction is not just survival, but creating a thriving, balanced ecosystem, where humans and other organisms can live permanently on Mars, turning it from a barren planet into a habitable world. Thanks for watching and exploring the science of terraforming Mars with us. The journey to make another planet livable is filled with innovation and wonder, and we hope it sparked your imagination. Stay curious, and don't forget to subscribe for more exciting insights into space and science.